July 23 was head and shoulders above any of the other months in the record that goes back to the late 19th century and is probably the warmest month going back many hundreds of years, though our estimates of precisely what was going on a month-by-month basis as you go further back in time obviously get a little bit more murky. But we're seeing these very large trends in the last century, certainly the last 50 years, and this is really just the epitome of the trends that we've been seeing. What's happening in July 2023 that makes this particular month so strong? We actually have lots of different things going on at any one time. So we have this large background state that's changing, right? The global warming that's kind of decade on decade just getting warmer. But then in any particular year or month, there's usually some natural variability in the weather that's adding to the changes or making it cooler. This year we have the beginning of an El Nino in the tropical Pacific. Normally we think of the El Nino having an effect, a lagged effect on the broader temperatures, maybe a few months after it peaks. The El Nino has not yet peaked, and so that will happen in December or January towards the end of this year. And so that's going to have a maximum effect, not this year, but next year in 2024. But right now it's adding a little bit. We have some, kind of pushes towards warmer temperatures from the eruption of Hunga Tonga in January of last year, which put a very large amount of water vapor into the upper stratosphere. But it's only large with respect to the stratosphere because the stratosphere is so dry. In terms of the total amount of water vapor is very small. And so that has a relatively small impact on global mean temperatures on the order of a few hundredths of a degree. But nonetheless, that's pushing us in a warming direction. We're also seeing reductions in air pollution, in aerosols and sulfates because of shipping, because of technology changes, because of efficiency in the Western world. There's lots of Clean Air Acts and people working through that. So that's cleaning up the air, and that is taking away an effect that was artificially cooling the atmosphere. And so now that's kind of being more manifest. And so that is something that, as we go on, is also adding to the warmth. The long-term trends, though, are still being driven by the increases in greenhouse gases. It used to be the case that we were only able to see the signal of global warming in the global mean statistics. But now it's so large that we can see it almost everywhere. So we can see the signatures of global warming in the heat waves in the American Southwest, in the heat waves in North Africa, in the heat waves in South America or in Asia. All of these things now have become more likely and more likely to be more intense because of that background global warming signal. The change in the North Atlantic has become much more likely because of that background global warming signal. And so now we don't need to just look at the global mean. We can look at local regional changes and we can see the signal of those long-term trends. It's not hidden by the noise, by the weather variability. We can see it clearly. So this peak warmth this summer, and that will continue, I think, mostly for the rest of the year, makes it quite likely that we will see 2023 as the warmest year. It's not completely certain, depends a little bit on how the weather plays out for the rest of the year. But as that El Nino is building, it will start to be, it'll be quite a serious event by the end of the year, and that will affect temperatures into the spring and summer of 2024, and it will almost certainly lead to 2024 being the warmest year on record, and will likely top 2023. So we've had this happen before, 1998, 89, 2015, 2016, where we had warm years that had a beginning El Nino, and then the year with the El Nino was warmer still. And then it kind of comes down again after that. But the long-term trends keep pushing it so that every time this happens, we are at a higher threshold, we're at a higher level, and the impacts are increasing much faster than the global mean temperatures. NASA has, as one of its main missions, is to look at the Earth and to study the Earth as a planet. And we use as much information as we can bring to bear on the question. We have satellites that are tracking water vapor, aerosols, temperatures, clouds, ozone, windiness. And then we match that with analyses of data on the ground. And so all of those things add up to give us a more complete picture of what's going on. And then we work by building models, by building simulations, by doing the attributional work. Why are things changing the way they are changing? And that involves piecing together all of the different fingerprints that we're seeing from the stratosphere to the surface, to the ocean, from the tropics to the poles, and try to piece it all together. We monitor the sun, we monitor the volcanoes, we monitor the temperatures, we monitor the greenhouse gases. NASA really tries to do it all. And unfortunately, when you do all that, when you put all of that together, what you find is that those trends that are driving these record temperatures, these record heat waves, they're due to our activities, not NASA, but people in general. And it's the emissions of greenhouse gases that are the dominant term in all of that. And that's not great to hear, but that is what the science says.